Yo, Mr. Lee here. Today's mini lesson is going to be one of the most important lessons I teach you all year. Okay, so if there's one thing you remember at the end of this year, I hope it's this. Of course, I want you to remember everything, but this is super, super important. Okay, so we're talking about representing the relationship between two variables, right? Often we're going to have x and y. There are going to be three representations. Okay, one's a graph, one is an equation, and one's a table. Okay, so there are three representations, three different ones. They're all going to look different, but they're going to tell the same story. Okay, so let's start with the general idea here. Okay, if I have an equation y equals 2x minus 3, I'm going to kind of skip to the end here, but then I'll show you how to make a graph from an equation from scratch. Okay, so start with the equation. It has some kind of graph to it, and if I look at all these points that are on the graph, okay, there are infinite combos of x and y. Okay, I'm clicking, holding, and dragging. Let's just take 3 comma 3, for example. Okay, this is telling me that specifically when x is equal to 3, my y value also has to be equal to 3. That's the relationship between the two variables, right? And we can do a simple calculation in our head. Right, think about this. If I do 2 times 3 for my x value, I'm going to get 2 times 3, which is 6. And then I subtract 3 from that. That's going to give me a y value of 3. Okay, so all the points you see on this graph, all the combos, they're going to make the equation true when you substitute those numbers in. All right? So now let's pretend that we do not have this graph given to us. Okay, so let's say you're given this equation and you want to graph the equation. Right? So this is how you figure out which points go on the graph. We can use this table here to help us out. It just helps us organize the points. Any point you see on this table can be put on the graph, and then that will show the general shape of what the graph looks like. Okay, so I'm going to pick a random value of x, and there should be a specific matching y value to it. Okay, so here's what I mean. Let's say I just pick x is equal to 0. This equation is going to be read as 2 times 0 now minus 3. Okay, so instead of 2 times x, I chose x as 0. It's going to be 2 times 0 minus 3. I'm going to run this calculation. 2 times 0 minus 3. You guys can check with a calculator or just do some mental math. The final y value should be negative 3 here. Okay, so when I have an x value of 0, my y value, based off the equation, has to be negative 3. And there's a point in the table, matching point on the graph. Okay, I'm going to go through some of these calculations pretty quickly, so definitely pause and rewind if you need to. Okay, but we're going to use the same rule. Y is equal to 2x minus 3, just with different x values, right? So I'm going to get more points to see what the shape of my graph looks like. So if x equals equal to 1, instead of 2 times x or 2 times 0, it's 2 times 1 now. Subtract 3. Final y value is negative 1. Okay, I'm going to keep organizing points on the table. If x is equal to 1, my y value has to be negative 1, right, based off my calculation. If x is equal to 2, same rule, right, my y value has to be equal to positive 1. If x is equal to 2, my y value is equal to positive 1. Okay, let's choose some more abstract numbers, some negatives. If x is equal to negative 3, it's still going to be 2 times x minus 3. So 2 times negative 3 minus 3. My y value is going to be negative 9. Okay, so when x is negative 3, my y value is negative 9. And last one, if x is negative 7, still 2 times negative 7 minus 3, I'm going to get a negative 17 for my y value. Okay, so when x is negative 7, my y value is negative 17. Okay, you can't see some of these points. Let me zoom out a bit. There they are, right? So we only tested 5 points. I said in the beginning there's going to be infinite points, right? But you should be able to see now the shape of this graph. We're gonna be able to create a line. Okay, so I tested enough points to get the shape of it, and now once I connect all the points, you're gonna see the full graph. Okay, and Desmos has a way for you to check that you've graphed it correctly. So definitely use that as a resource. But that's kind of a snapshot of this whole graph equation table concept. Okay, so graph equation table, GET for short. Don't forget it.